First we measure this flask, but before we do that, we must tare the scale to 0. Now we can measure this flask by opening the lid and putting this massive object to this scale. We close it. As you can see, it is 19.430 grams.
By rinsing it with water solution 3 times. After priming the pipette 3 times, we have to rinse with the solution water to prevent any extra dilution.
So this is going to be the concentration of dilution equation. So we have the equation right here. C1V1 equals C2V2, where C1 is the concentration of the stock solution and V1 is the first volume delivered. C2 is the concentration of the diluted solution and V2 is the given volume of the volumetric flask. We do some algebra here. We're trying to find the concentration of C2, so we ended up here. C2 equals C1 V1 divided by V2, and you get those numbers over here we got from the data. We plug it in, do some algebra, and then we got 1.48.
In order to read the volume, we need to read at the bottom of the meniscus.
The meniscus is a curve in the upper surface of a liquid in a tube. The meniscus occurs because surface tension is created within the liquid. This happens when the molecules of the liquid are attracted to those of the container, and it is determined by holding the instrument at eye level and observing the bottom of the curve.
About 3.95. The initial volume is at 3.95 if you read under the meniscus. You need to put it in the volumetric flask. The final volume at the bottom of the meniscus, which would be 12.81.
After delivering the solution to the volumetric flask, we must add the blue water until the meniscus aligns with the marked point.
So now we have this fluid in this volumetric flask. Let's weigh it, but first we must tare it to 0. Now we can weigh it by opening the lid, placing this inanimate object, close the lid. Now we can see the measurement is 44.371 grams. After completing the lab, you must dispose all liquid solutions in the sink and solid waste in the waste compartment. Remember to wipe down your lab station with a wet paper towel and to wash your hands before leaving the chemistry room.
In order to find the concentration of the unknown sample number 369, we must find both the mass and the volume. And in order to find the volume, we take the difference of the final and the initial volume, and you get 1.78 milliliters. Then, when you take the difference of the final and initial weight, which results in 25.162 grams. And in order to find your Y value, which is your density, you do mass over volume. And when you do that, you get 1.0065 grams per milliliter. You plug this value into the Y of your trend line to find X, which is also the concentration you need to find for your unknown sample, which results in 1.322%.